Hello everybody, my name's Phil Prosser and I'm a domain solution architect here at Red Hat. I focus on all of our integration technologies and our app dev technologies. Some of you might have seen me talk about 3 weeks ago. I did a tech talk actually, which was sort of an introduction to Quarkus, and also then I did a sort of demonstration of building your first application with Quarkus. One of the mistakes I made in that session was to not record it, and therefore we couldn't put it up onto our YouTube channel. So what I'm doing here is now just doing another recording, but this time just doing the building of your first application with Quarkus. If you want to see the presentation I did, we recorded a lightning talk just last week, which will take you through what Quarkus is and what the value of Quarkus is. So for today, I'm just going to demonstrate to you building a simple create, read, update, delete API using Quarkus. And really the goal of this is to show you that it's nothing to be afraid of. It's very similar to using microprofile. In fact, it is using microprofile. So if you've got server-side Java skills, or even, dare I say, JEE skills or Jakarta EE skills, the move across to Quarkus should be pretty straightforward. And so what I'm going to start by doing is showing you sort of how you get started. So where do I start? And so we support two mechanisms of building Quarkus applications. One is using Maven and the other is using Gradle, which actually is in tech preview at this point in time. I prefer to use Maven for my builds, and so that's what I'm actually going to show you. There are a few ways that you can get started with Maven and with Quarkus. One of the ways, which I'll quickly take you through, is by actually going to the Quarkus.io website. While I'm here, this is also a really good place and lots of good content around type of things that you could do with Quarkus. So I highly recommend coming to Quarkus.io and having a look around. So for example, if you wanted to see how to do things to start with, you can click on the get started to look at guides, which are really useful to do things. So for example, if I wanted to deploy as an AWS Lambda, oops, if I could spell it, Lambda, then on here you can see a guide that will take you through the process of doing that. So it's really, really useful and a really, really good website to get up and started with Quarkus. All right, so we're going to build some code today, and my whole goal is just to show you how simple that process is and how you end up getting maximum value out of Quarkus, and I'll come right at the end. So to start with, I can click on my Start Coding button, and by going to Start Coding button, what I'm able to see here are all of the different extensions that exist within Quarkus. And if you go back and look at my presentation, you'll see I allude to the number and quantity of extensions that we have, and they are growing all of the time. So as I go down here, you can see there are sort of many different extensions covering lots of different capabilities that you might want to use when you're building your applications. So all I need to do is I can choose. So here I've chosen OpenShift. I could choose that I want to do some Vertex work with reactive programming maybe. I want to do some messaging with small line messaging and randomly choosing things. And at that point, what I'm then able to do is to generate an application and download that as a zip file. And that will give me, because I've selected Maven, if I wanted Gradle, I could choose Gradle here. But with Maven, it would create me a zip file, or I can push directly to GitHub, or I can share it via other mechanisms with other people as well if I chose to. This is using community Quarkus and upstream Quarkus, so there is no support here at all from Red Hat. Now, if you are a Red Hat Runtimes user or you are an OpenShift user, then you're entitled to get support for Quarkus too, and therefore you'd want to be able to download the enterprise version of the Red Hat build of Quarkus. And to do that, you can click on this little link here, and that will take you over to a different site. And we effectively have exactly the same process now, but we're loading and downloading the binaries and dependencies that are those that are supported by Red Hat. So you've got choices there. Now, for the demo today, what I'm going to use is I'm actually going to use VSCode. So we provide a really nice plugin for VSCode that supports Quarkus very well. And as part of that support, it also allows me to start building my applications as well. So here I can see that I can generate a new Quarkus project, and you'll see that the workflow is very similar to that I would see on the website. So now I can pick my build tool. So I'm going to pick Maven. Then we can choose our group ID that we want for Maven. We can then choose the artifact ID that I want for Maven, the version. Then I can choose my package name for my Java application, or the default package name at least. And what the Maven archetypes do is they'll actually build for me a sort of default REST API that I can sort of use as to get started with. So here, that's called Hero Resource. So I press generate, and now the final thing it asks is the list of extensions that I want to use. So just like we could see on the website, there are all these different extensions down here that I could choose. Basically click on them, and then it will create a dependency POM file that has all of those things built into it automatically. So I'm cheating slightly because I've done this before, and all I need to do is choose the last used extensions that I picked, just to save a little bit of time. So if I choose last used, that will go away and it builds me a downloadable application, and I'll generate that application at this location here. So we'll add that to my workspace, and we can see now that we have a new application built in called REST Hero Demo. So if we look at this, we can see that simply it has a Java class, and that Java class is simply a JAX-RS API, REST API basically. So I can run that, and one of the things that if you go back and listen to my presentation, I talk about this concept called live coding. And live coding means that I can run the application once, I can make as many changes to that application as I want and test it without the need to actually restart my application or JVM at all. So to do that on the command, I'll just make sure I'm in the right location on the command line. Let's just get cd rest hero rest hero demo, puts me into the right directory. And then all I need to do is I can run a Maven goal, which is now underneath my record sign. Let's move that up. Maven Quarkus -dev. So we've got a particular plugin called Quarkus for Maven that has a goal called dev. And what that will do is start my application up. Now, again, you'll have heard me briefly talk in the presentation about extensions, and extensions having both a build time and a runtime part to those extensions. When we run in developer mode, we basically load both parts of the extension, so that the build time can work dynamically as I change code, or as I save code, as I run pieces. And then I have the runtime, obviously, to be able to execute those changes that build time worked out. So let's just test this application to start with. So it is just a simple API. So all we need to do is go http://localhost 8080, and it is listening at hello. I'm looking at the source code now to see where it's listening. REST easy. If I've got that right, there we go. We can see that's responding back to me here saying hello REST easy, which is actually the piece of code here that's been returned. So just to show the live coding piece in action, I can make a simple change there. So let's make a space. I can save that change, execute again, and now we can see there's a space there. I've not recompiled, I've not restarted the JVM in any shape or form. It's just recognized that change straight away. So I'll get that. I'll take that little space back out for now. Now, as we build this little application up, I don't want I'm going to leave hello in there as a service that's available, or a method that's available, but I don't want it to be the default one. And at present, it's the default one because basically it's on the sort of main path. So what I want to do is first off change my path. So what I'm doing is I'm going to create a little CRUD service that reads heroes, so superheroes from a database table basically. So we'll call the main path of that hero. And what I want to do is then to add a path to this method, and this path will call hello. So let's just check that that works. So we should be able to come back to the command line on my curl. Oops, I can't type that in for some reason. There we go, 8080. And then we typed in hero, and we typed in hello. Okay, so we can see that again, that's redeployed, recompiled, sorted itself out without me having to do anything, and I get my answer back. So that's all well and good. So what I'm going to start by doing now is use Hibernate and Panache to generate an object relational class that will map to my database for me to basically read, write, and update the data from my database. So to do that, I'm going to create a new file, and that file is going to be called hero.java. And that will now create me the sort of starter class for me. Now, the beautiful thing with the Quarkus plugin is that we have lots of code snippets available as well. So if I type in Q, you can see here I've got Q Panache entity. So I can literally press that button, or if I press the right button, press the wrong one. If I choose Panache entity, there we go. We can see it will generate for me a sort of default Hibernate-based Panache class for me. So I don't want to use base. So basically base means I have full control over my ID, and I don't need that. I'm going to let Hibernate look after the primary keys for me, just for the basis of this demo. I don't want any of this stuff that's built in. I'm going to give it my own data model, and that is represented here. So I'm just looking at my other screen to copy that out to save some time, and we'll just paste that in here. So we've got the data model coming in, and if I format that document, we can see it's pretty darn straightforward. So we've got an ID, a name, another name, and a picture and powers and a level, and that's sort of it. The final thing I'll do is just generate a toString as well. So we've got a toString available in there, and that's nice, and that's done. So the beautiful thing about Panache is it gives me a whole load of help classes as well that I can use, which means things like finding by primary key, finding all, and a whole load of other features I don't need to code anymore. They're all part of this sort of object that I'm inheriting from here, which makes things nice, easy, and very quick to do. And so the next stage is that I'm going to write a service, and that service is going to be controlled by the Quarkus container. So I'm going to use CDI basically to inject this service back into my API when we get there in a couple of minutes. So we're going to call this service hero service.java. And so in this service, what we're going to do is we're going to make it application scoped so we can inject it. So choose, again, the nice thing about VSCode here is that it's helping me all along and doing all my imports as I go, so I don't have to. And then what I want to do is create a new method. And what I want to do on this is return a list of all of the heroes, basically, that are in the database. So we'll just do hero, I beg your pardon, a list, and we'll choose the class hero. And then what we'll do is we'll call this find all heroes. That will do. Now we can do a return, and if I look at my hero, we can see these helper methods all starting to kick in now. So I can just do list all. So I've not had to do anything to actually go get that data from my objects and from my database. Ultimately, it's all done for me under the covers. We'll just do exactly the same thing again, but this time we're going to target a particular primary key rather than just going for them all. So this time we're just going to return a single hero. And we're going to find hero by ID. So we need to provide an ID. I can't quite see the color code in it. So it's going to be a long, and we'll call it ID. So all we need to do then is return hero dot, and we can see here there are find by ID. So it's find by ID. I just have to choose the right name for the ID that gets typed in. So that's all cool. And we can see that that's saved. Now, bear in mind, I've still not restarted my JVM at all. The JVM is still sat there running away. So in theory, I should be able to live code all of this work as we go. So the sort of final step in the gluing this thing together is to actually plug this service into my sort of RESTful front end service, hero resource here. So the first thing that I need to do is I need to inject. So we're using the inject annotation to be able to do that. I choose the right one. I'm wrong now. There we go, inject. And what we're going to do is hero service. We'll call that hero service. There we go. So that will give me my hero service instance without me having to do any work whatsoever. And now all I need to do is create some more methods that we're going to expose via my API. So let's create a new method here. And what we're going to return this time is a JAX RS response. So here we are. We're going to return a response, and we'll call this method get all heroes. That should do the job. Let's call it get all heroes with a T rather than R. That would be helpful. So get all heroes. So all we need to do now is return a response object, and we're going to just do happy path. So everything's okay with the world, and we're going to talk to the hero service, and we're going to talk to the find all heroes. Oops. Going to find all heroes, and then the final thing we do is build. I've put too many here. Build the JSON object to respond. How does it know it's a JSON object that I'm responding with? It doesn't just yet. So what I need to do now is to annotate this method to make it available as a API. So we're going to say this is a get. We're also then going to say, well, this is on the default. So if somebody talks to hero, I just want them to call get all heroes. So I don't need to define a path for this. But what I do need to do is to instruct what type of media I want output. So we're going to choose a media type of application. I can't type now. Application underscore JSON. Oh, the wonderful world of live demos. Okay. The final step on this is to do a similar thing, but get finding by ID. So let's do public method. So this is going to look fairly similar to the one we've just done. So we're going to return again a response document, and this time we'll call this get hero by ID, or words to that effect. That will do. And then we'll do a long ID, just like we did before. And this time we'll return a response. Okay, from hero service. And we're going to do get all by ID. And then finally, we'll do build the response and sort of almost good to go. So the final step on this now is to do a piece of annotation work. So we can do get, and we'll stop after this. This is enough, I think, to sort of prove the point that this is just pretty much normal server-side Java that we're doing and sort of micro-profile work that we're doing. And we'll call this application underscore JSON. And the final step is now we do want to specify a path. So this has a bit of dynamicness on the path, and that is called, put it in quotes, Phil, that is called, it's a substitution, and it is ID. So I want to substitute whatever comes across in ID into the actual parameter that's being passed into the method. So the way I do that is that I can come down here and I can specify a path parameter, and we give the path parameter name that we're interested in, which is ID, and that's all good. So that means that we can sort of substitute that path parameter into the parameter ID, and that is then sent across to my query. So that all looks pretty good to me. So let's just go and give it a test. So we've not done anything to restart this application at all, but in theory, if I was to do hero, what's going on here with my keyboard? Let's go hero 1, for example. Let's put that to JQ. We should be able to get data back. Now there's a problem. So it hasn't actually worked at this point, and there is a good reason why this hasn't worked. Basically, I haven't wired my application up to my database in any shape or form at this stage. So it's sort of thrown an error. But the point is, it has still tried to execute. And I've done radical change to this since we actually started with the simple Hello World service without stopping the JVM. So can I continue without stopping the JVM? That's the question. So what I need to do is I have a local Postgres database that holds all of my heroes in, and I need to be able to access that database. So I define all of the properties in application.properties to connect my database into this. So again, in the plugin, we have this super helper that will generate everything that I need. And what we start seeing here is everything I need to do to connect into my Postgres database. So it's listening on localhost. The name of the database is, I just need to check make sure I get the name of the database correct, is heroes_database. Heroes_database. And then the username is not overly secret, it's just Superman. And the same is true with the password. So the password again is just Superman. Now, one of the things that you might see on the left-hand side here is that we have %dev. So what I'm able to do is to have different versions of these values based on whether I'm running in development, whether I'm running in test, or whether I'm running in production. So that's a good way of being able to substitute these things in the different environments depending on what I'm actually running at. So for the sake of this demo though, I'm just going to say, well, let's run everything the same. Don't care if I'm running in dev, test, or production. Just want it all to be the same, but I'll just switch the log off when I go out of development. So if we save that, what we should be able to do again now is just try this query once more. And bingo, we're working. So, and also we're logging the actual queries to the database out. So I've managed to create a very simple application that's now talking to my database. And we can see that it's returning all of the data. So there's quite a lot of data in that database, and it's returning lots of different superheroes. Incidentally, you can actually run through this workshop yourself. It's online. So if you search for Quarkus workshops or Quarkus superheroes, you'll find a sort of step-by-step guide on how you can actually go and sort of build this type of application. All right. So as far as I'm concerned, and my development is done, that's tested and working. So what I want to do now is package it up to execute. So it's the very first time I've just stopped the JVM there. Everything I did was while the JVM was running. So to package the application in Maven, no rocket science involved. I type in Maven package. And that will go away and actually build my application for me. So it will run some tests against it. And then it will package that up. So again, we've got sort of full integration with JUnit and technologies like that for testing. Ooh, and we can see it failed. Now I know exactly why that failed. It's failed because I've changed the default endpoint. But the thing I wanted to point out here as well is that we can do testing of the application. And then if I choose to take my application, I'll talk about this briefly in a few moments, and take it to natively compiled code, then I have separate testing that I can do for that stage of compilation as well. So if there's other things that I want to test beyond just making sure that my application works, I can separate those two things out. So we can see here that this endpoint is still very much the same endpoint that we had when this thing was generated, and that's why the test is failing. So if we say that's hello, you'll see there's if we go through there, there's a 404 in there, and I think it was hero, if I remember correctly, I typed in. Hero, yes. So hero/hello should be the answer to that. So let's just try and compile that again, package that again. And we'll see this time if the test actually works. Test looking good. Let's now package the application up. So I've now got a jar file that I can execute to run this application. So if I type in Java minus jar, goes into the target directory, and we can see here I've got a rest hero-runner.jar. That's my application. We can run that application up and we can see it started. So again, one of the values I talk about in the presentation is just how quick Quarkus can start. So that's the first time it started up as a Java app, and it took 2 seconds to actually start that application up, which is far quicker than any of the other sort of Java microservice-based application frameworks that are out there. So it's executing. Let's just make sure it still works. So nice, still can get all my data from the database. I can still get a particular individual. We also have things like metrics set up and things like Open API. I'm not 100% sure whether I've got those set up now, but let's just have a look. So if we were to go, let's take that out. So /Open API. There we go. So we've got the Open API documentation automatically generated for me as well. And again, I've done nothing to be able to do that. That's just happened as part of the application. I also end up with Swagger UI if I want to, and that's generated automatically without me having to do anything as part of this application build. All right, so that shows a Java version of the application executing with real quick startup time. And also we'll see that I've not done any memory tuning of this application yet, but if we just look, we can see here, if I type in Java, and let's just make sure this is the right one. So yeah, running in REST Hero demo, we can see that we've got a memory footprint now of 272 megabytes, which is still pretty high at this stage, but I know with some JVM tuning, I can probably easily at least half that, and if not more, once I've tuned that up. But as you can see, I've just ran Java -jar. I've not specified any sort of startup memory settings or anything like that. But it's not bad to start with. So, but you'll hear as well in my talk that we do have another method of compilation, and this is what we call compile into native code. So this is going to take 2 or 3 minutes for it to execute. So let me just get this going first. How do I compile to native code? I put profile of native on the end, so pretty straightforward, and I can press that button. Now this process can take 2, 3, and even sometimes 4 minutes to execute. So it's my job now to talk while it's doing it. And so if you listen to my presentation, you'll actually see that this is using a VM that we call at Red Hat Mandrel, which is a downstream version of Groll VM that allows me to take my code and actually compile it down into a native executable and get rid of the need for actually using a Java virtual machine at all. And what we've seen, and again, you'll see these in the presentation that I gave, that there's a massive decrease in startup time. So even a 2-second startup time is pretty quick for a Java application. But if I can get it even smaller, then all the better for running in the world of serverless, either on platforms like OpenShift or in hyperscalers like AWS using things like Lambda, for example. So it can make a massive, massive difference to the overall sort of footprint of a Java application when it's executing. So what's actually happening now is that Mandrel's basically executing my application. It's actually working out how all of the code actually hangs together and what calls what. It's then going to build up a native application that only includes the classes that are required at execution time for my application. So unlike when we run on Hotspot, for example, the Hotspot JVM is exactly the same size, regardless in terms of the memory it will take up and the classes that it has in it, regardless of the applications that run on top. Here, the only things that are in my executable are those classes that are required, both from the JVM itself and obviously from my application. So as you can probably see, there are a few gotchas that could happen there. So if you're using reflection, for example, in your application, this process is likely to miss those classes at execution time, and therefore you would normally get a Java class not found exception if you were to run these using native code. However, we do have annotations that we can use with Quarkus as well to say that this particular class that I'm using is used for reflection, and therefore include it always, regardless of what you actually see going on. Okay, so again, we can see the work going on here. It's getting towards the end of its process now. One of the other things that I can do, so I'm currently running on a Mac, and when I run on the Mac and just type in -p native, that's actually building an executable that will run on a Mac. It's not building an executable that could run in Linux or in OpenShift, for example. So I can specify other parameters as well to get it to generate native code for a Linux-based platform. And to do that, I use sort of Docker under the cover on my machine to actually download a Linux container and do the compilation in that Linux container. All right, so we're almost here, and it's a bit like watching paint dry for me now, but we're very, very close to it getting to the point of finally compiling. All right, so there we go. So what I should see now, if I do an ls in my target directory, we should see now that I've got runner.jar, which was the thing that we executed earlier as the uber jar file, but also have this new one now, which is just runner, has no extension on the end. That is my executable. So if I run that guy, that's my application executing. So we can see here that the execution of the startup time has gone down, even for Quarkus, which was just over 2 seconds. We're now looking at 0.143, so 143 milliseconds to start up. That's an enormous improvement already by running in native code using Quarkus. So again, I can illustrate that best by saying, well, can I actually get from this window to that window and execute a request and get it fail because it's starting up too slow. Let's see if I can do that. So we can see that trying to move from the left to the right, it's starting up so quickly that I just can't get there quick enough to be able to do it. I'll try it again. I'm always in for the challenge, so let's try it again. Nope, couldn't do it. Let's try it with a big one. So let's do the full query, see if that will catch you now. Nope. So it's starting up quicker than I can actually sort of move my mouse literally from the left to right. Now, I know it's not scientific in doing that, but you'll see in my presentation again, when we talk about the startup, not just the startup time, but the time to first response. So we always know that when we start a hotspot application, generally the first response in particular is relatively slow, and gradually it gets faster as hotspot does its work. Here you can see that the time to first response is pretty much instantaneous. So the moment it's available, it's executing. The final thing that I just wanted to show you, and you'll see this in my presentation, because of the concept of the extension having runtime and build time, and now only having the runtime available to me at production time, and that saves me a lot of memory. But now, because I've got native code as well, and a lot of the Java classes that my application doesn't require have been completely stripped away, both on the JVM and from my application level, and of course any dependencies that my application has as well, means that I should see another big saving in memory. So not only good startup time, but massive reduction in memory. So let's go just checking that out to see if that's the case or not. I forgot what the application was called now. Blank moment coming up. It's REST. REST. Here we go. REST demo runner. So if we look at this guy executing, we can see it's not a Java process anymore. And what we have now is an application that's taken up real memory, 57.1 megabytes of memory. So we've gone down from just over 200 megabytes of memory, I think it was, down to 57 megabytes of memory without me doing a thing other than just compiling the application into native code. Again, I know I could probably halve this again with some tuning and get this down to sort of between 20, 25 megabytes of memory as well. So massive memory savings and massive improvement in startup time. So what isn't there to like about using Quarkus? So I plan to do some more of these sessions in the future. I plan to do something maybe around Spring. So how can I do something similar using an API written in Spring and executing that on Quarkus? Look out for that, hopefully early in the new year. So again, thank you very much for your time and look forward to speaking to you all soon. Thank you.